So section 5.1 was taking the derivative of all the ln functions. So this section is integrating them. So it's going backwards. So we still have to know some college algebra properties to be able to do this. But the first thing that we have to be able to recognize is that if you see 1 over x and you integrate that, we get the ln of absolute value of x plus c. So we've done this before. You've done it on quizzes and stuff before. So just recognizing that 1 over x, if you integrate that, it gets you to ln of x. Now, the same thing applies if it's 1 over u. So again, our u substitution is going to apply here as well. So if you do 1 over u du, again, it's the ln of the absolute value of u. And remember, it's absolute value because you cannot take the natural log of a negative value, and then plus c. So let's look at the two examples at the bottom. Lauren, what do you think we would get for the 3 over the ln of x? Or sorry, 3 over x if we integrate?
Would it be ln of 3?
Not quite. Think of this. Remember, we can pull the 3 out. So it'd be 3 and
3
1.
ln.
There you go. So it's going to be 3 ln. And then let's make sure we always remember that absolute value of x. And then what else do we need? There's one part that's missing.
Plus c.
Plus c. Okay, so now the next one doesn't work quite that easy. So we have to think about our u substitution that we did previously. So if we were doing our u substitution and we're dealing with ln, usually your u is going to be that denominator. So in this case, I'm going to let my u be 2x squared minus 4. So if we're doing u substitution, remember we have to find du. So du is just the derivative of your u. So what is the derivative of my u, Connor?
4x.
And then I need my dx. Now, if I look here, I have an x and a dx, but I don't have a 4. Everett, what do I need to do with that 4?
Divide it over.
Divide it over. So I would have 1/4 du equals x dx. So when I do my substitution, I'm actually integrating. I'm going to go ahead and pull that 1/4 out front, but I'm integrating 1, oops, I did it twice. 1 over u du. Now, if you integrate 1 over u du, just like it says up here, you're going to leave the 1/4 out front. It'd be the natural log of the absolute value of u plus c. Then we just have to substitute back in. So we're going to have 1/4 ln absolute value of 2x squared minus 4, and then plus c. Does everybody see what happened with the u and the du part on that one? So again, if it's not just a number over an x, we do have to use that u substitution. And generally the u will be the denominator. So if you take the derivative of that u and replace it, again, if it doesn't match perfect, like here we didn't have the 4, we had to divide the 4 over and then replace. Now, there are other instances here, and this is kind of where the college algebra part will come into play. It says use long division before integrating, okay? Anytime the power in the numerator is larger than or equal to the power in the denominator. So I'll give you a second to write that down. So if you're looking at the problem that's given, we're integrating x to the fourth plus x minus 4 over x squared plus 2. So in this case, our power in the top is our 4 and the power in the bottom is 2. So we have to do some long division. And if you think back to college algebra, we're gonna have to set this up. Now, a lot of times if you look here, we go from x to the fourth to x, and then we have a -4. We're skipping some powers, so we may have to add some powers in there. So sometimes it's good to go ahead and put that in there to begin with. So I'm going to put a plus 0x cubed plus 0x squared plus x, and then a -4. Now, remember how to do this. You ask yourself, what do I multiply x squared by to make it x to the fourth? So what do I multiply x squared by to get x to the fourth? Well, that's x squared. Oops. Then you take x squared times x squared. That gives me x to the fourth. X squared times 2 gives me a 2x squared. But then remember, we have to subtract. So when we subtract, we change both of the signs. So this is going to cancel. If we go down, we have a -2x squared plus x. We bring down our x here. Then we say, what do we multiply x squared by to get a -2x squared? Well, we need a -2. So if we do that, we get -2x squared, and then we get a -4, which is actually going to be over here. Then we have to switch our signs. So if we do that, that cancels, and we're just left with an x. And the x would be our remainder. So if we were to write this out, our problem would now look like this. X squared -2 plus x over x squared plus 2, because that's what we were dividing by, dx. So what you're doing is you're doing that long division to be able to rewrite the problem. And again, you do that long division if your power in the top is bigger than the power in the bottom, or it's equal to the power in the bottom. Now, to integrate this, you integrate every piece individually. Well, the first two pieces are pretty easy. We can integrate those. If we integrate x squared, Emily, what do you get? I don't know, I can't hear you.
1/3 x cubed.
1/3 x cubed. What about a -2, Jasmine?
Zero.
Well, you're integrating.
Oh, never mind. X squared.
Just -2.
-x squared.
-2x, because there's no x there. Now, this last piece is harder. And I'm going to leave it as the integration here. Because what are we going to have to do with that last piece? Freddie, what are we going to have to do with that?
You need to split it into 2 separate pieces.
Well, you can't split it into 2 separate pieces. We have to use a different technique.
Yeah. Oh, yeah, you have to use substitution. Yeah.
Yeah, you're going to have to use the u substitution. So in this case, again, like I said, usually the u is going to be your denominator. So our u, we're going to let be x squared plus 2. du is the derivative of that. Marissa, what's the derivative of that?
Sorry, what?
What's the derivative of our u?
2x dx.
2x dx. Oops. Now, again, it matches pretty close, but we're off by the 2. Mary, what do we need to do with the 2?
Divide by 2.
Divide by 2. So we'd have 1/2 du equals x dx. So if we look at what we're doing here, we're replacing. So this piece is going to look like, again, I'm going to pull that 1/2 out in front. So I'd have 1/2, and then I would have 1 over u du. Now we've already integrated the first pieces. So now we have to integrate these last piece. So when you integrate 1 over u, again, that is the absolute value. So I'd have 1/2 ln the absolute value of u plus c. Now, that's not my final answer. I have these other pieces, but I also need to substitute back in what my u is. So my final answer would look like 1/3 x cubed minus 2x plus 1/2 ln the absolute value of x squared plus 2 plus c. And that would be my final answer. So again, that's a long process because you're going to have to do your long division. You're going to have to get it divided into the pieces. Some of them might be easy to integrate, and usually the first ones are very easy to integrate. But then you're probably going to have to do that u substitution with another piece. Now, again, like I said earlier, the u is usually the denominator. Take the derivative of that, then we had to adjust it to make it work. So we had to divide by the 2 to get the 1/2 du. Do our substitution and integrate that piece. And that's what we got when we integrated. And then make sure your final answer includes all the separate pieces. All right, so here's some additional ones. They don't quite all match up to what we were just doing. So this is a little bit different. If you're looking at that first one, we're integrating the ln of x squared plus x, over x dx. So if you're looking at that one, again, we're going to do our u substitution. But if we're doing that u substitution, what would our u need to be in this one? What do you think? Think back to when we were first doing u's. We said it's usually whatever's on the inside. What's on our inside, Tate?
ln of x.
Ln of x. So we're going to let u be ln of x. Then our du then would be what, Connor?
1 over x dx.
1 over x dx. So if we look at this, we can actually rewrite that and have it look like ln of x squared times 1 over x dx. That's really exactly the same thing as what we had here. It's just written a little bit differently. Okay. Now, if we do our u substitution, it actually works nicely. We would have u squared 1 over x dx, we can see here is equivalent to our du. So if we integrate u squared du, Eli, what do we get?
1/3 u cubed
And then what else do we need? Missing one thing.
plus c.
Plus c. And then substitute it back in. So we would have 1/3 times ln of x cubed plus c. And that would be your answer. Now, what about the next one? If we're looking at the next one, Everett, what do you think we could use for the u?
The x minus 2.
X minus 2. So what would your du be?
It'll be dx, just dx.
Dx. Now, this is similar to that question 16 that you guys struggled a little bit with on the test because it doesn't match up real nice. We can replace this bottom with the u. We know dx is du, but what's the piece that was missing that we were struggling a little bit with? Freddie, what are we gonna have to do here?
Well, you're gonna have to like substitute u for x.
Right, we have to get rid of this x here. And to do that, we're gonna solve for x in this top equation. And x would be u plus 2. Okay, so if we do this, I can leave this, I can pull this 5 out front. We don't need it there. But I'm gonna replace the x with u plus 2. In the bottom, I would have u to the third, and we know dx is equivalent to du. So we're going to, if we're doing this integration, remember we had to divide these pieces individually. So I'm going to leave that 5, but I would have u to the first over u cubed, which is going to give me u to the negative second plus 2u to the negative third. So we divided each piece individually. We took u to the first over u to the third plus 2 over u cubed. Now we have to integrate each piece individually. Lauren, if I integrate that first u to the negative second, what would I get? Remember, we add 1 to our exponent. Marissa, can you help?
Negative u.
Negative u to the what power?
The negative first.
The negative first. Then the next one we'd have to integrate 2u to the negative third. Mary, what would I have there? Integrating this.
Negative 4u to the negative 2.
Well, not quite, close though. Remember, we would divide by that exponent, so we're going to take 2 divided by a negative 2, which is going to give me a
Just negative 1
negative 1.
or negative u.
Yep. And then we need our plus c. Now we can distribute our 5 through. So we would have negative 5 over, I'm going to go ahead and replace my u. So that is going to be in the bottom. I'm going to have negative x minus 2. Sorry. And then minus 1 over, and then I would have x minus 2 squared plus c. So that problem's a little bit harder. We have to do that u substitution, but we have to remember that every x and every dx has to be replaced and turned into a u. So we can't just pull that x out front. We have to replace it as well. Questions on that one?
Does the 5 not like distribute to the
Oh,
other
yep, I
one?
should have had the 5 on the second piece. So it should be here too. I can't get it to right. Okay. All right. So, and these are going along that same idea, but there's going to be a little more substitution involved here. So if we're looking at this first one, again, when we're dealing with these ln's, like I said, majority of the time, the u that you're going to use is going to be the denominator. So that's where I'm going to start. I'm going to let u be 1 plus the square root of 2x. So Tate, what would my du be?
Hold on, I'm writing it out.
Okay.
Negative x to the negative 1/2. Oh wait, no, it's derivative. Sorry.
All right.
Is it 3x to the 3/2?
Remember the exponent, you just move out front. So it'd be 1/2. Leave the inside alone.
Oh,
Subtract 1 from your exponent. And then we need our dx. Now, why did I drop the 1? What's the derivative of 1?
0.
0. All right, so I'm going to rewrite this a little bit because this is really that du is equal to 1 over 2 square root of 2x dx.
Don't you have to multiply it by 2 as well?
Oh, yep, we forgot that. And then that 2 goes away. So we just have 1 over the square root of 2x dx. Now the problem is I don't have a square root of 2x on the top. I only have a dx. So if I'm solving for dx, then I would say I need to multiply by that square root of 2x. I'd have square root of 2x du equals dx. But now my problem's getting really messy. But let's look at this first part. Could I solve that for the square root of 2x? Well, it's similar to what we were doing earlier. We could subtract 1 and say the square root of 2x is equivalent to u minus 1. So instead of writing this here, I could write u minus 1 du equals dx. Because remember that our ultimate goal is to get everything in terms of u's. We don't want any x's. So then that's going to allow me to say that this is 1 over u. Instead of dx, I'm replacing it with u minus 1 du. Does everybody see where that is coming from? Okay, so if you multiply that through, we can actually make this easier. It'd be the integral of 1 minus 1 over u du. And we can integrate that fairly easy. If you integrate 1, that's going to give me, and I'm going to move this all the way over here. That's going to give me u. Minus if you integrate 1 over u, that's the ln of the absolute value of u, and then don't forget your plus c. Then substitute back in. So we'd have 1 plus the square root of 2x minus the ln of the absolute value of 1 plus the square root of 2x plus c. And that would be your final answer. So what I want you to do is think along the same terms of what we just did and try this one down here on the bottom. So I'm going to give you a couple minutes. Try it and then we'll go through it together. Because this is like the hardest type of questions that you would have. Kind of give me a thumbs up when you are finished so that I know if you're done. How's it going? Not good, I guess. Get an X. Do you guys want more time or do you want me just to start going through it?
Start going through it.
Okay. So in that case, can somebody tell me what they would use for your U?
Would it be square root of x minus 3?
Correct. Square root of X minus 3. Now du, what is your du then, Marissa?
One over 2 square roots of x dx.
Correct. 1 over 2 square root of X dx. Now, this is where we have to do a little bit of adjustment. So we only have a dx. Now our square root of x is on the top, and that's going to make this one a little bit hard too. So again, I'm going to get my dx by itself. So really 2 square root of x du. Now the nice thing is I know what, I can figure out what square root of x is equivalent to. Square root of x would be equal to u plus 3. How many of you got to at least this spot? Okay, so a few of you. Now, there's going to be multiple substitutions in this one, and that's what makes this a little bit harder even than the one that we just did. So we are going to integrate. Where it says square root of x, we're replacing that with u plus 3. In the denominator, we want that's going to be our u. Well, here's our problem. We have an x here, and we can't have the square root of x in there. So we're going to replace that square root of x as well. So we're going to have 2 and then u plus 3 du is equal to dx. So we have to replace this big long piece in here for our dx. So we're going to have times 2 u plus 3 and then du. Anybody get to that spot? Couple? Okay. So now we have to actually multiply all of this out. So my iPad just locked up, so give me a second. So go ahead and if you have not, multiply that out. So I would multiply the 2 times the u plus 3, multiply that, and then multiply that solution, what you get for that, then times the u plus 3. All right. So what I was saying is multiply this piece through. So it would be 2u plus 6. And then we have to multiply that then by the u plus 3. And we're still over the u. So if we distribute across the top, we'd have 2u squared. And then it would be plus 6u. Plus 6u plus 18 all over u. And you're integrating that one. But we can combine these middle pieces. Now, we've been integrating pieces like this for a long time. What do we have to do with this piece to get it to where we can integrate each one individually? Eli, what do we need to do?
Divide each part separately.
Correct. Divide each part separately. So we would have 2u plus 12 plus 18 over u du. So if we integrate this very first piece, Emily, 2u, if you integrate that, what do you get? For some reason I can never hear you.
Emily's mic isn't working, so she's gonna have to, I'll speak through her, I guess. And she is gonna say that's actually u squared
Okay,
plus 12u. And then I can't do that last part off the top of my head.
you can do it.
So-
It's 8
It's
over u.
9u.
Mhm.
No.
If there's just a u on the bottom, it's an ln.
Oh yeah, ln of
So it'd be
u
18 ln absolute value of u. And then Eli, what is the one?
plus c.
Never forget. Plus c. And then we need to replace it. And so we have so many things in here. We've got to go back and see what was our u. Remember that our u was the square root of x minus 3. So now we have to substitute that in. So we would have square root of x minus 3 squared plus 12 square root of x minus 3 plus 18 ln of the absolute value of square root of x minus 3 and plus c. So again, lots of substitution. Questions on that? Okay. So some other things that you need to be able to do, and these are ones, some of these we've talked about already. These are your integrating your trig functions. So we know when you integrate sine of u, you get negative cosine of u plus c. Now, we've always used x's, but u's, it doesn't matter. If you integrate cosine, you get sine. So those are the ones that we've really done so far. Now, notice that when you integrate tangent of u, it's negative ln of cosine of u. So these are some new ones that you may need to write down. Again, these are ones that are located inside of your front cover as well. So again, when you integrate cotangent, notice it's the natural log of sine of u. Secant of u is the natural log of secant u plus tangent u, and cosecant negative ln, the absolute value of cosecant u plus cotangent u. So again, several different ones that you might have to use as you go through as well. If you are taking the AP test, these are ones you have to have all this stuff memorized. If you're taking it for dual credit, they do allow you to use, it's a formula sheet, but it's very similar to what's in the front cover of your textbook. Anybody need more time to write these down? And that is not your homework. Your homework is actually the WebAssign that's on 5.2. It's worth 24 points, I believe. So you need to at least get on and look at it today and start it. That's how I'm going to give you your points for today, is just, I want to see that you get on and attempt something on that assignment. Questions on that? This is what we will be working on tomorrow as well in class. So you'll have time to ask questions and stuff, but really try to get on there and get started so that you know what those questions would be.
And what is it gonna be due?
I think I have it set towards the end of the week,
Okay, thank you.
but we will be doing another section this week as well. At least one, if not two. Anybody else have any other questions?